Discuss the conceptual questions of chapter 2. So there are basically 9 conceptual questions. I'm not going to discuss the whole the answers from your textbook or the answer that I've shared with you, that included in the notes. I'm just going to discuss the main concept of each conceptual question over here, right? So starting with the first one, the first question says, is it possible that displacement is zero but not the distance? Under what condition displacement would be equal to distance? So basically we have to see what is distance and what actually is displacement. So we are given a case where the displacement should be zero but distance should not be zero. First of all, discussing the definitions. Path followed during the journey is called distance, right? So for example, a cart just starts from here and starts traveling and ends at the point B right over here. So let's say it's point A and this is point B. In this case, this path, this curved path followed by the car is actually the distance. This is the whole path followed by the car during its journey. But what exactly is displacement? This displacement is the shortest path between initial and final position, the shortest distance between initial and final position. So you can see I have drawn a straight line because जब भी हम लोग दो dots को join करते हैं, then in that case shortest path जब हम लेते हैं, it means that we have to draw a straight line. Okay, जितना path curved होगा, it means उतना ज़्यादा distance increase हो रहा है, उतनी ज़्यादा length हम increase कर रहे हैं. So shortest length किस केस में होगी? Of course एक straight line के केस में. Therefore this straight line represents the displacement. This is the shortest path between point A and point B. So ऐसा कौन सा केस हो सकता है जिसमें हमारे पास डिस्टेंस तो हो, इट मीन्स कि हम लोग ट्रैवल ज़रूर कर रहे हैं, लेकिन हमारे पास डिस्प्लेसमेंट ज़ीरो हो. इट मीन्स कि जहाँ से हमने जो इनिशियल पॉइंट हमारा है, जहाँ से हमने जर्नी स्टार्ट की, एग्जैक्टली उसी पॉइंट पर आकर हम लोग स्टॉप करेंगे. फॉर एग्जाम्पल वी टेक द केस ऑफ दिस रेक्टेंगल. इन दिस केस मैं एक कार लेती हूँ एंड ये कार पॉइंट ए से ट्रैवल करना स्टार्ट होती है टुवर्ड्स पॉइंट बी. ओके, पॉइंट ए से पॉइंट बी एंड देन पॉइंट बी से पॉइंट सी तक, देन सी से डी तक एंड देन डी से ए तक. सो इस कार ने एक रेक्टेंगुलर एरिया कवर किया फ्रॉम ए टू बी, बी टू सी, सी टू डी एंड अगेन फ्रॉम डी टू ए. सो इसने एक रेक्टेंगल फॉर्म में ट्रैवल किया. इन दिस केस you must know that there is a distance that is traveled by this car. Okay, एक path उसने ज़रूर follow किया है. This is the whole path that this car has followed. But is there any displacement? Is there any distance between the initial position and the final position? No, the initial position is A and the final position of the car is also A. There is no distance between initial and final position. दोनों केसेस में हमारे पास जहाँ से हमने जर्नी स्टार्ट की वहीं पर आकर स्टॉप किया. सो क्या हम यहाँ पर पॉइंट ए और पॉइंट बी से लेकर इनिशियली और फाइनल पोजीशन से तक हम क्या एक लाइन ड्रॉ कर सकते हैं? नो, बिकॉज द इनिशियल एंड फाइनल पोजीशंस आर द सेम. In that case, there is no displacement. We cannot draw a straight line between the starting and the ending point. Therefore, for the case of any closed path, मैं सिर्फ इस रेक्टेंगल की बात नहीं कर रही, आप स्क्वायर के केस में भी बिल्कुल ऐसे ही कर सकते हैं, आप सर्कल के केस में भी, आप किसी भी इरेगुलरली शेप्ड लूप के केस में भी ऐसा ही कर सकते हैं. एज लॉन्ग एज द पाथ इज क्लोज्ड पाथ. क्लोज पाथ वो होता है जो जहाँ से स्टार्ट हो रहा है वहीं पर स्टॉप हो. सो इन दैट केस फॉर एनी क्लोज पाथ द डिस्प्लेसमेंट is 0, but the distance is not necessarily 0. Right? So this was the answer for question 1. Question 2 says that does a speedometer measure a car's speed or velocity? Speedometer आपने cars में use किया होगा, देखा भी होगा. That speedometer, of course, it just measures the speed, but because it does not tells us anything about the direction of the car. The speed is associated with the magnitude only, and the velocity measures its magnitude and direction as well. In this case, in the case of speedometer, the direction is not included, right? So as the direction is not included, so it can't be velocity. It could be speed only, because speed is the only thing that involves the magnitude only. So in speedometer, we can only measure the speed, and we cannot measure the velocity of the car or anything that is moving with a certain velocity, a certain speed, right? So speedometer is used to measure the speed only. It's not used to measure the velocity. Question number 3 says, is it possible for an object to be accelerating and at rest at the same time? एक्सप्लेन विद एग्जाम्पल. सो क्या ऐसा हो सकता है कि हमारा कोई ऑब्जेक्ट हो वो एक्सेलरेट भी हो रहा हो एंड एट रेस्ट भी हो? ऑफ कोर्स वी कैन टेक एन एग्जाम्पल ऑफ अ बॉल. ओके, एंड इफ यू टेक अ बॉल एंड थ्रो इट into the air, it would follow this kind of curved path, right? हम अगर यहाँ से अपनी बॉल को थ्रो करते हैं, बॉल यहाँ से ट्रैवल करना स्टार्ट करती है, एक पॉइंट आएगा, ओके, इन दी अपर डायरेक्शन. जैसे ही बॉल जाकर इस पॉइंट पर पहुंचेगी, सेंट्रल हाईएस्ट पॉइंट पर, इट विल स्टॉप फॉर अ मोमेंट. ओके, उसकी वेलोसिटी हाईएस्ट पॉइंट पर 0 हो जाएगी. इट मीन्स एट दैट पॉइंट एक्सेलरेशन ड्यू टू दैट वेलोसिटी विल बी 0, of course. Lekin there would also be another velocity that would be acting upon that ball, and that velocity would be that acceleration would be the acceleration due to gravity, g, which is equal to 9.8 meters per second, right? Okay, so in this case बॉल के पास इनिशियल वेलोसिटी है, वेलोसिटी से वो ट्रैवल भी कर रही है, उसकी वजह से उसके पास एक्सेलरेशन भी है. लेकिन एक पॉइंट ऐसा आएगा जब उसकी वेलोसिटी 0 हो जाएगी, बट वो रेस्ट पर होगी, उसकी वेलोसिटी 0 होगी, बट देयर वुड बी एन एक्सेलरेशन दैट वुड बी एक्टिंग अपॉन दैट बॉल, एंड दैट एक्सेलरेशन वुड बी द एक्सेलरेशन ड्यू टू gravity, right? Question number 4 says that can an object have zero acceleration and non-zero velocity at the same time? Give examples. So of course it can have zero acceleration and non-zero velocity, because if the velocity is just the rate of change of um, position, how much we change the position of a body with respect to some time. But acceleration is the rate of change of velocity with respect to time. It does not depend upon whether there is a velocity or not. If we have a velocity and that velocity is not changing, it means that we don't have an acceleration. Okay, acceleration does not necessarily mean that if there is a velocity, there must be an acceleration. अगर यहाँ पर हमारे पास acceleration है, it means that there is a change of velocity. Take an example of a ball or a car which is traveling with 5 meters per second, right? But it does not change its velocity throughout that journey. It stays moving with a velocity of 5 meters per second. Therefore, in that case, there is no acceleration because it's not changing its velocity, right? So the acceleration of that car would stay 0 meters per second square. Question number 5 says, a person standing on the roof of a building throws a rubber ball down with a velocity of 8.0 meters per second. What is the acceleration, both in magnitude and direction, of the ball? Okay, so we are given a scenario where a person who is just standing in his window, and he just throws this ball in the downward direction. Okay, जैसे ही वो बॉल थ्रो करता है, वो बॉल नीचे डाउनवर्ड डायरेक्शन में मूव करना स्टार्ट करती है. सो वी आर जस्ट आस्क दैट उसका मैग्नीट्यूड क्या होगा एक्सेलरेशन का, एंड डायरेक्शन क्या होगी. डायरेक्शन वुड बी downwards, right? And the magnitude would be 9.8 meters per second square. Why we don't just calculate it out using 8.0 meters per second? Because it does not matter whether we throw it with 8.0 meters per second or 12 meters per second or whatever it is, right? The acceleration due to gravity upon that ball would stay constant, right? This is case of free fall motion, and for the case of free fall motion, the acceleration due to gravity will stay constant for that certain planet. So here we are discussing it, of course, for the planet Earth, and for planet Earth that acceleration is a constant, and its value is 9.8 meters per second. Question number 6 says, describe a situation in which the speed of an object is constant while the velocity is not. So this is the case that you are going to study in rotational motion or dynamics as well. In this case, you can take an example of a circle, right? So circle के case में मैंने आपको पहले lectures में बताया था that for a circle, the direction of its velocity is always tangent to the circle. Tangent क्या होता है? It just means that it is perpendicular to the radius. So जब भी मैं tangent to the circle की बात करूँगी, it means that I'm talking about the perpendicular vector with the radius. क्या मतलब है कि हमारे पास ये जो velocity है v, this is tangent to the circle. Tangent means that this vector which is used for velocity, this is perpendicular to the radius. ठीक है? So it means अगर आपका object यहाँ है, it means exactly at this point the direction of its velocity will be in the forward direction. ठीक है? इसकी direction of velocity की direction, I'm not talking about the magnitude. The direction of this velocity will be just perpendicular to the radius. But what happens when this object reaches this point? At this point, the direction of its velocity will again be tangent to the circle. It means that it will make an angle of 90 degree with the radius. So you will see that at every point, अगर ऑब्जेक्ट यहाँ पर पहुँचता है तो उसकी वेलोसिटी की डायरेक्शन कुछ और है. अगर ऑब्जेक्ट यहाँ पहुँचता है उसकी वेलोसिटी की डायरेक्शन कुछ और है. अगर आपका ऑब्जेक्ट यहाँ पर पहुँचेगा, इट मीन्स वेलोसिटी की डायरेक्शन कुछ और है. इट मीन्स कि थ्रू आउट द जर्नी in a circular path, the direction of its velocity keeps on changing. But what about the magnitude? The magnitude of that object will remain the same. If we keep the magnitude same, it means कि अब उस बॉडी की स्पीड सेम है, बिकॉज स्पीड ओनली इंक्लूड्स द मैग्नीट्यूड, सो स्पीड सेम है बट वेलोसिटी चेंज हो रही है. बिकॉज वेलोसिटी की का मैग्नीट्यूड यहाँ पर सेम है बट डायरेक्शन चेंज हो रही है. सो डायरेक्शन चेंज इन डायरेक्शन इटसेल्फ इज अ चेंज, राइट? सो देयरफॉर द वेलोसिटी इज चेंजिंग बिकॉज देयर इज अ चेंज इन डायरेक्शन, बट द स्पीड इज द सेम बिकॉज देयर इज नो चेंज इन द मैग्नीट्यूड, राइट? So this was all we had to discuss in question 6. The speed is magnitude, so it remains constant, but velocity has direction also. Therefore, it changes at every point whenever a body travels in a circular path. Right? I just move the camera. Okay. Question number 7 says, can an object have a northward velocity and a southward acceleration? Explain. This is a simple case. If we take a car, right? The car is moving towards the north. Let's suppose this is the north direction. In this case, the car is moving towards the north. So the velocity is towards the north. But the person applies the brakes and the car suddenly starts to decelerate, right? Or it starts to just coming toward the stage of rest. It just starts to come towards रेस्ट स्टेट. ठीक है? सो इन दिस केस जब भी आपका ऑब्जेक्ट डिसेलरेट होगा या रेस्ट में आने की कोशिश करेगा, इट मीन्स दैट अब आपका ऑब्जेक्ट एक फोर्स अप्लाई कर रहा है इन द डायरेक्शन ऑपोजिट टू दैट ऑफ द वेलोसिटी. एक ऑपोजिट डायरेक्शन में फोर्स अप्लाई हो रही है. दैट अप्लाइड फोर्स causes an acceleration but in the opposite direction. So जब भी आपका ऑब्जेक्ट डिसेलरेट होगा, इट मीन्स के स्लो डाउन होगा. सो स्लो डाउन के केस में आपकी वेलोसिटी की डायरेक्शन एंड एक्सेलरेशन की डायरेक्शन ऑपोजिट होगी, राइट? सो इन दिस केस आपकी वेलोसिटी नॉर्थवर्ड है एंड जो आपकी एक्सेलरेशन है वो साउथवर्ड है. ठीक है? क्वेश्चन नंबर 8 says, as a freely falling object speeds up, what is happening to its acceleration? Does it increase, decrease, or stay the same? So we are given a case of freely falling body, right? So जैसे ही आपकी body freely fall करना start होती है, it means it is speeding up, right? उसकी speed constant नहीं रहती, उसको speed up हो रही है. So speed up तो हो रही है, but क्या constant rate के साथ speed up हो रही है? इंक्रीजिंग रेट के साथ स्पीड अप हो रही है या डिक्रीजिंग रेट के साथ स्पीड अप हो रही है? सो द आंसर इज दैट फॉर फ्री फॉल ऑब्जेक्ट, प्रोवाइडेड दैट द रेजिस्टेंस द एयर रेजिस्टेंस is neglected, for any kind of free fall object, remember that this acceleration is constant for every certain planet. Usually we take the example of Earth. Therefore, for the Earth, that constant acceleration is called the acceleration due to gravity, and its value for really low heights is constant. which is 9.8 meters per second square. So for this case, in the absence of air resistance, the gravitational acceleration is constant. Therefore, the body would just fall downwards with the constant acceleration. Okay? Question number 9 is a ball is thrown upwards with an initial speed of 5 meters per second. What would be its speed when it returns to the starting point? Here we have given the case of free fall again, provided that this is the case of where we neglect air resistance, neglecting air resistance, you can say. So after a ball is launched, there will be no force on that ball except gravity, right? Air resistance is neglected and there is no force on that ball except gravity. So there would be only gravitational force that would be acting upon that object. So as only gravity acts on that object, therefore there would be only gravitational acceleration that would be acting upon that object. And gravitational acceleration only changes in direction whenever a body goes to a certain height and comes back to that initial position. So in this case आपकी gravitational acceleration की just direction change होगी लेकिन value same रहेगी provided that there is no resistance and you can say that there is no external force that is acting upon that body. So in this case of free fall motion, so after a ball is launched, there would be no force on that ball except gravity. So only gravitational force will act on that body. So as object returns at the same point, its velocity will be the same as initial velocity but in the opposite direction. So अगर 5 meters per second की स्पीड से या वेलोसिटी से हमने उसे थ्रो किया था, so उसी स्पीड के साथ वो वापस exactly उसी पॉइंट पर वापस भी आएगी. Right? So these were all the conceptual questions. If you still have any question, let me know in the comment section. Thank you so much, everyone.